Alright, let's take a look at one last problem. Now, I'll tell you right now, this one's going to be a little trickier than the rest. And it has to do with negatives. And as far as a fraction goes, you probably wouldn't get tripped up by it. But over here, what we want to do is reduce this fraction like we always do. But this negative, for us, isn't that big a deal in this case because we can just think of it as negative 1 as its own factor. And then 20, in this case, since 16 is the bottom number, I think specifically I want to break this up into 4 times 5. Okay, but pay attention to that negative 1 we've kind of set to the side because that's going to become important on this problem over here. Now, 16, if we're going to try to cancel things out, I'm thinking the best breakup for the factors would be 4 times 4. That way, this 4 can cancel with one of these. And when I put it back together again, I get negative 1 times 5 over 4, which just becomes negative 5 over 4. Now the thing to pay attention to here is how we took that negative factor, that factor of negative 1 out of the problem, kind of left it to the side and then reincorporated it back in. Similar thing here. Let's take a look. Now the top, no big deal. I can see that 3n and 12 share a common factor of 3, so I can take that out. And so that'll become 3 times n minus 4, so two factors. But now down here, to me this looks kind of like our difference of squares shortcut, but it's a little bit backwards, and in fact it is, because what's going on here is they multiplied in a factor of negative 1, and so what we're used to seeing is reversed around. So here's what we're going to do. I'm going to take out a factor of negative 1 out of this. Now here's what will happen. Positive 16, well, if you think of it, negative 1 times what would give you a positive? Well, it'd be another negative, so it'd have to be negative 1 times negative 16. Then here, minus n squared. But if we take out that negative 1, the minus becomes a plus, and we get plus n squared. Now, still, this doesn't quite look like anything, so what we're going to do next is this. Recopy the numerator. And in the denominator, we're going to still leave that negative 1 to the side. But now here, to make it look like a little more like I'm accustomed to, I'm going to switch these. I'm going to put the n squared in the front and then the negative 16 second. So we get n squared, and the negative basically becomes a minus 16. Now this is what we're a little more familiar with. This is our difference of squares shortcut, which we can then break that up and factor it a little further. So leave the top alone. Leave the negative 1 off to the side, but then n squared minus 16 becomes n minus 4 times n plus 4. Now we didn't see that before because this again was kind of the reverse of what we're used to seeing, but now I can see that these exactly match up, n minus 4, n minus 4, and I can put the whole thing back together again. And since I'm out of space over here, I'm just going to put it over here. I get 3 negative 1, which I think the easiest thing, I'm just going to put the negative out front. So there's our negative 1 right there. And then on the bottom, n plus 4. So negative 3 over n plus 4. And that's my answer. So you can see how that negative 1 can kind of fool us sometimes. It's easier to deal with it in a regular fraction, but with rational expressions it's going to be a bit trickier. So look for these spots where things seem almost backwards of what we're used to, and see if taking out a factor of negative 1 can fix things so it's more like what we're used to.